Vera Rubin was born Vera Florence Cooper. And Vera was born on July 23rd, 1928, in the great city of Philadelphia in Pennsylvania. And as you can see here, she is an astronomer and a galaxy explorer. And yes, when she was little, she built a homemade telescope with the help of her dad. Her academic career started, of course, in elementary school, and she went to school in Philadelphia at the time, and it was not segregated. Colors and creeds all went to school together. But her father ended up getting a job in the DC area. This caused her to have to move, and because of that, she ended up experiencing segregation at her school in H.D. Hook Elementary in Washington, D.C. It also states on here that her discoveries proved that dark matter existed. So she uncovered the discrepancies between the predicted and observed angular motion of galaxies. But before we get into that, let's learn a little bit about her background and her parents. Now, Vera is, again, from Philadelphia, but both of her parents are actually immigrants that came from Jewish families. Both of her parents have Jewish backgrounds, and both of her parents were fleeing just general Jewish oppression in Eastern Europe. And that is the reason that they came to New York, which is where her parents had met. But her father was from Latvia, which is now Lithuania. And her mother is from Moldova, which is present-day Ukraine. One of the interesting things about her father was that he was an engineer that worked for the Bell Telephone Company. In the year of 1938, the family moved to Washington, D.C. when Vera was 10 years old. And this is when she really started to be more interested in looking up at the stars. And one of the main reasons was because her sister and her shared a bedroom, and her sister, being the oldest, got to choose where she would put her bed first, which means that Vera got the side of the bedroom that had the window, and she was able to stare up at the sky on many nights, and she was a very smart girl. Her dad actually used to love to play number games with Vera and her sister. And so this helped her to understand and see patterns very easily in the night sky. But again, when Vera moved to Washington, D.C. at H.D. Cook Elementary School, she did experience segregation. But at the same time, she was also able to go to Paul Junior High, and there she was able to develop a greater interest in the stars, and that's when she was 15 and made her own telescope for the first time. Now, of course, her dad did help her with the telescope. She was able to make it out of cardboard and, a piece of glass that her dad had helped her to sharpen. One of the other reasons why Vera was so drawn to study galaxies and study the stars was when she was 12, there had been 3 separate encounters of Jupiter and Saturn coming together. And on these 3 separate occasions between when she was 12 and 13, these instances were one of the main reasons why she became so fascinated. Another thing that happened between 1940 and 1941 was that there was a geometric storm that sent out solar flares and caused an aurora to come over all the way down to Washington, D.C. And she remembers her parents taking her over to the East Potomac Park and then watching. It was an aurora in down to Washington, D.C., which was really spectacular. Vera also mentioned that in Paul Junior High was where she really experienced her first bit of sexism with her physics teacher, who really put her off on physics. That's why she didn't become an astrophysicist and did not like to be referred to as an astrophysicist because she was, in her mind, an astronomer. She did not like physics. And it all stems from this high school physics class teacher. But good thing that Vera did ignore this particular teacher's advice, who told her not to go into science, and she did. She ended up graduating from Coolidge Senior High School in 1944. And from there, she went on to Vassar College, and it is an all-women's school in New York. And it was one of the very first to have an observatory. And this observatory, so Vassar College Observatory was completed in 1865, and it is associated with Maria Mitchell, which was America's first professional female astronomer. She is actually known for identifying a comet. At Vassar College, she was a member of Phi Beta Kappa, and she earned her bachelor's degree in astronomy in 1948. And after this, she actually attempted to enroll in the astronomy program at Princeton, but was barred due to her gender. But also by this point, she had met her future husband. And this would actually determine where she would get her master's at. And that would end up being Cornell, because that is where her husband ended up going. Vera and Bob married June 25th, 1948. Bob had been in the Navy, and the Navy had sent Bob to Cornell to study chemical engineering. At Cornell, she worked with astronomer Martha Carpenter on galaxy dynamics and studied the motions of galaxies. From this work, Rubin made one of the first observations of deviations from the Hubble flow. Through her conclusions, there was an orbital motion of galaxies around a particular pole were later disproven, and the idea of galaxies were moving held true and sparked further research. While at Cornell, she had her first child, and in 1951, she gained her master's. From here, Rubin studied next at Georgetown University, where she earned her PhD in 1954 under George Gamow. For Vera to get her PhD, it was a family undertaking, and I want to tell you guys how Bob, her husband, and Vera worked together along with Vera's parents, Pete and Rose, to make sure that she was able to do this. Bob, her husband, would drive to Vera's mother's house and pick up her mother, Rose. Rose would have a packed lunch for her husband, Pete. And Rose would then be driven over to Vera's home where she was with the children. And Bob, her husband, would drop her mother-in-law off and pick up Vera. Vera and Bob would then go to Georgetown University, where Vera had packed a lunch for Bob, and Bob would sit and eat his lunch while Vera rushed into her class. Later that night, Vera's father, Pete, would then drive to Vera's home where his wife was, and they would have dinner together and watch over the kids while Vera was at her course. I really feel like this family working together to help Vera get her doctorate degree is honestly something really amazing and something that you really don't hear in 1954. So she had 2 kids and graduated with her PhD by the time she was 25. She's a pretty amazing person. For the next decade, Vera worked various short academic positions in the greater DC area. She served for a year as an instructor of mathematics and physics at Montgomery College in Maryland. And then from 1955 to 1965, she worked at Georgetown University as a research associate astronomer and lecturer from 1959 to 1962. And then finally, assistant professor of astronomy in 1962 to 1965. So in her later positions in 1963, she began a long-year collaboration with Geoffrey and Margaret Burbidge, where she made her first observations of rotations on galaxies while using the McDonald's Observatory, an 82-inch telescope. She joined the Carnegie Institute of Washington in 1965, and she was a staff member in the Department of Terrestrial Magnetism, where she met her long-term collaborator, Kent Ford. During her work at the Carnegie Institute, Vera applied to become the first female astronomer permitted to observe at the Palomar Observatory in 1965. By doing this, she initiated a relationship with the faculty at the Vatican Observatory that continued until 1986. Vera retired from Carnegie Institute in 2014, and she was a senior fellow astronomer in the Department of Terrestrial Magnetism. Now let's get to her actual research. At the Carnegie Institution, she began work on her thesis regarding the galaxy clusters, and then she continued this with Kent Ford, making hundreds of observations using a image tube spectrograph. The image tube spectrograph allowed the resolving the spectra of astronomical objects that were previously too dim for any kind of spectral analysis. And so a decade of observations came together in a shared discovery of Rubin and Ford's effect, with the publication first appearing in 1976. The Rubin-Ford effect. So basically, the Rubin-Ford effect is the expansion of the universe on a scale of 100 million light years. And this was discovered through the studies of spiral galaxies, particularly in the Andromeda galaxy, chosen for its brightness and for its proximity to Earth. The idea of a particular motion or a spiral motion was still a controversial position or proposition at this time. And so this particular work that she did was dismissed by a lot of astronomers, but ultimately showed to be very valid. The effect is also known as large-scale streaming. Later on, she began to study the rotation and outer reaches of galaxies, an interest that sparked her collaboration with the Burgundens couple. She investigated the rotation of curves of spiral galaxies and began with the Andromeda galaxy. She observed flat rotation curves. The outermost components of the galaxies were moving as quickly as those close to the center. She further uncovered the discrepancy between the predicted angular motion of galaxies based on the visible light and the observed motion. Her research showed that spiral galaxies rotate quickly enough that they should fly apart if the gravity of their constituent stars was all that was holding them together. Because they stay intact, a large amount of unseen mass must be holding them together, a conundrum that became known as the galaxy rotation problem. So this galaxy rotation problem was what became cited as evidence that spiral galaxies were surrounded by dark matter. So Rubin's calculations showed that galaxies must contain at least 5 to 10 times more mass than can be observed directly based on the light emitted by ordinary matter. Rubin's results were confirmed decades later, and it became a first persuasive supporting theory to the dark matter theory, which was later confirmed by radio astronomers and discovered the discovery of cosmic microwave background and the images of gravitational lensing. So Vera was super, super smart. She did a great job and was a wonderful person. She worked really hard for women's rights and, just forward movement for women. She has so many things that she was given and granted: the National Space Grant, the Older Planetarium Life Achievement. She worked for the Clinton administration. She got the Dixon Prize for Science. She was the National Medal of Science winner in 1993. She just did so many amazing things. Vera worked really hard to get women in science and women in astronomy. She was even one of the people that helped the Cosmo Club in Washington, D.C. become integrated with women as well as men.
All right, just a few minutes here, real quick. For those of you who don't know, I'm the chair of the Arkansas Natural Sky Association, an environmental group concerned with light pollution, trying to advocate for responsible lighting. We've largely lost our connection with the night sky. You have to come out to a place like this to have a half-ass chance of it. There's no naturally dark place left in Arkansas, totally naturally dark, even the Ozarks and the Ouachita National Forest. And it's not just a matter of losing the stars, it's also a matter of wildlife impacts and human health, the American Medical Association tells us. So that's the Arkansas Natural Sky Association's agenda is public education and spreading the word. And we got invited to go to astronomy night at the Arkansas State University campus in Mountain Home. It has been a long time since I've been to Mountain Home, like maybe 40 years. The last time I was in Mountain Home, it was a little tiny, sleepy place, a typical Arkansas backwoods town. Even then, they were saying it was Chicago's southernmost suburb, but it has really changed, and they have a beautiful campus there, and which I was very impressed with. And Jennifer Wiseman, Dr. Jennifer Wiseman, who's the senior project scientist on the Hubble Space Telescope, was their featured speaker for this astronomy night. And so we were invited, and so I said, okay, well, we'll go to that. And we took our Stella's Outdoor Lighting Academy tent that you're seeing here that we created last year and showed for the first time at the Dark Sky Festival, which we hold each year. The last 3 years spent at the Bear Creek log cabins property north of Marshall, just south of the Buffalo River. This year we will hold it there again, October 2nd and 3rd, by the way. So save it on your calendar. Uh, at any rate, we've shown this tent, I think, 4 times since. But this was just a few weeks ago at this event, and Jennifer Wiseman, Dr. Wiseman, is from Mountain Home, so you can imagine that she drew a crowd. Yeah, she came from there. and she spoke at our festival year before last. And the year before that, Amber Strong, who is a project scientist on the James Webb Telescope from from B Branch, Arkansas, was our featured speaker. So we ran out of space telescope astronomer women from Arkansas after those two, and we had to resort to something else last year. But at any rate, I digress. This is our tent, and we had it set up inside in their auditorium, and I'm just going to fly through these. We had over 200 people go through it in not quite an hour, and then I had to quit counting to go out and give my constellation tour. But so I just jumped through these pictures quickly. As you can see, people are taking that tent in. Now, this is the auditorium. It seats 850, and Jennifer filled it up. In fact, there was over, you can't see here, they actually had portable seats back here to the left. So it was a big deal. And Mountain Home, Arkansas. Yeah. Well, you know, if you have a Hubble Space Telescope astronomer that's born there and she comes back and talks, you turn out a crowd. Uh, they surely did, and we were really tickled to be able to service that. Say again? Yes, if you go straight up the center of the state and stop just a little bit before you get to Missouri, maybe, I don't know, 30 miles as a crow flies or something like that, short of Missouri. Yeah. So anyway, that's my little short report, and thank you. Any questions? I'm happy to answer. All right. Say again. Get some of the what's turned off. Billboards. Oh, yeah, yeah. Well, if we could just get them to light them right correctly, you know, put the light up and shine it down, not down and shine it up. But yeah, well, and the power companies keep renting these LEDs that look like egg cartons. You know, like they're full of eggs, and they're way too bright, and they aim them at an angle, and they're way too blue, and it's awful. It's just awful lighting, and but people get it. We are making some progress. We got Hot Springs adopted its ordinance last year. Little town of Goshen improved their ordinance. We've got, I think we have 7 outdoor lighting ordinances in the state now. And so we got the Mountain Home Library has adopted a responsible lighting program. CAAS library system, the whole system here in Central Arkansas adopted responsible lighting practices. So it's a matter of bandwidth and energy and time. We got a lot more possibilities. The state parks have adopted light management plans for their parks. Everything grandfathered in, of course, so it'll be slow in seeing effects. They're trying to get Mount Magazine designated an international dark sky park, which they have to change the lighting for that. Yeah, my wild guess is about 35,000. Well, it used to be, yeah, about a tenth of that. All right, thanks.